In this video for section 2.2, we're going to start by talking about bar charts. A bar chart displays qualitative data. The height of each bar represents the frequency or percentage of observations for each category. We can have a bar chart with either horizontal or vertical bars. So on the left, we have a bar chart that shows the number of new cars sold for different automobile companies with vertical bars. On the right, we have a bar chart that shows horizontal bars, and the graph on the right also displays two different variables. So we have each automobile company, and we also have the years 2014 and 2015. So we can compare the sales for the different companies to each other. We can also compare within one company the sales in different years. Another way to display qualitative data is with a pie chart. A pie chart is a circle that is divided into slices, and each slice is proportional to that category's share of the entire data set. So looking at this pie chart, I see that golf ball is the largest percentage, and it's also the largest wedge or slice in the pie chart. Now, it's important to know that a pie chart is appropriate only in situations where the slices of the pie represent parts of a total. So it makes sense to have the total number of values added up. Now, if it's percentages, then it always makes sense to use a pie chart. Sometimes with raw numbers, we also have data that is parts of a whole, but sometimes we don't. And in some cases, it doesn't make sense to use a pie chart. There's an example in the textbook of a case where there's a pie chart that doesn't make sense. If it doesn't make sense to use a pie chart, then a bar chart should be used instead, because a bar chart can be used to compare parts to other parts without considering the whole. Lastly, we're going to talk about stem and leaf diagrams. A stem and leaf diagram can be used to display quantitative data. So we have bar charts and pie charts for qualitative data, stem and leaf diagrams and histograms for quantitative data. A stem and leaf diagram is similar to a histogram, but it shows the actual data values. So we have an example here of a raw data set. This is number of patients at a walk-in clinic each day for 200 days. And this is the stem and leaf diagram of that data. So when we look at the stem and leaf diagram, we can pick out the individual values by combining a stem with a leaf. So for example, at this 6, this represents 60, and these two 2's here mean that there are two values of 62 in the data set. So if I go back to my original data set, I should find two cases of 62 in that set of numbers. So when we're making a stem and leaf diagram, we separate each data value into a leaf and a stem. The leaf is always the rightmost digit. It could be the ones place of the number, or it could be the tenths place of the numbers if they're decimals, and you'll see an example like that in the homework. We list all possible stems from lowest to highest, and then the leaves in order from lowest to highest next to the appropriate stems. So you see in this example that for each stem, the leaves are listed in order from 0 up through 9. And if we have multiples of the same data value, then we list that number repeatedly. So for example, there are 3 values of 89 in my original data set. So that's why I have 3 9s here. So that's a stem and leaf diagram.